Yes.
So here we have 2 times 4, it's going to be 8. And what about x? I think you have noticed that we have the same base. Let me try to write it down. So what about the exponent? I need to add them together. I need to combine those 2 terms together. So this one, it would be x to the power of 8, right?
Yes.
So the first law that we have right over there, whenever we have the same base, which makes sense that we need to add the exponent together. But what if we have something else? Here we have a power 3, p power 2. This is called algebraic term. I'm trying to multiply term by another, which makes sense. This one seems like a power 3, p to the power of 2z, right? For example, let me try to change it into c, for example. Right now, we have a to the power of, I try to add them together, so a to the power of 6, right? What about b? I'll do the same thing. So b to the power of
4.
Yeah, exactly. And I tried to bring it down because we don't have any other C, so it seems like, uniquely, so we don't have any other one. So I tried to bring it down. But what if you have something else, for example? So let me try to go over the second one. Whenever we have the same base and we have, dividing operation, which makes sense that we need to subtract the power. For example, if you have right over there x power 3, y to the power of 2, x power 4, y power 1, for example. This one is a quite bit different. Why? Because I really care about which one is greater than the other. I know that we have x to the power 3 and x to the power 4, right? Well, it makes sense that x power 4 is greater than x power 3, right?
Yeah, right.
So I need to subtract them together, but you have to write it in the greater side. And as you can see right now, the greater side, the lower part, right? So I'm going to write just x. And I try to subtract 4 minus 3, it's going to be just x. What about y? Y is
Hold on, I have
supposed
a
to be,
question. Why don't we
yeah,
do x power 3 minus x power 4, which is x minus 1, power of 1.
yeah, because this is going to be the next lesson. The negative power. Right now, أنا لسه ما اتعاملتش مع النيجاتيف. It makes sense that
Okay.
I'm trying to deal with the positive one firstly. And
Okay.
after,
Okay.
after perfecting it, you'll be able to deal with the negative power, right?
Right. Okay.
So I ended up with y over x. But this one, to be honest with you, almost of the students make the same mistake. They think that I don't have to care about which one is greater than the other. So y over x is going to be the same thing of x, y, for example. But this one seems like common mistakes, right? So you have to be careful. Where should I write it? Did you get it?
Yeah. Okay.
Okay, let me try to go over something else. What if you have z power 6 y multiply z y power 3? How could I do this one? Seems like it's kind of multiplying, right? Over z power 7 y to the power of 2. So I need to multiply, I need to get the expansion of this one firstly. So it makes sense, this one's going to be z power 7, right?
Right.
Because I tried to add 6 and 1. It's going to be 7. What about y?
Y my well, y for power 4.
Yeah, and then here we have z to the power of 7 over y to the power of 2. This one's been canceled. We no longer have that. Or you could say that z to the power of 0, which makes sense. This one's supposed to be 1. Because you know that any number raised to the power of 0, it's going to be 1, but 0, right?
Yeah.
So the last thing that you need to do is just try to subtract those together. So it's going to be y squared, or y to the power of 2. Makes sense, right?
Okay. Yeah, makes sense.
So we have, a couple rules that we have been talking about. The first rule, whenever we have the same base, we need to add the exponent together if we have multiplying, right? And the second rule that we talked about it when we are trying to divide them together, we need to subtract the power from each other. But what if we have, something else? What if we have, for example, 4a power 2b to the power 3, all to the power of 4? This one is a quite bit different. We need to distribute the power which has been written, outside the parentheses all over every single term inside it. Let me show you how. This one, I need to distribute 4 all over every single number inside it. So it's going to be 4 power 4, right? What about a? A to the power of?
8.
8, yeah, perfect. What about the last one?
12. B to the power of 12.
So b to the power of 12. Sometimes he tries to make it just much more harder. Sometimes he tries to, to manipulate it. Sometimes he'd ask you if you have, 4x power 2, y to the power of something, for example, raised to the power of 4. And this one seems like y to the power of something. And he told me 4 to the power of something, x to the power of something, and y to the power of 16, and try to figure out, the missing. So definitely we have 3 missing. So let me try to work out the first one. You have to ask yourself, here we have 16, right? So it makes sense that we have 4 times something. It's going to be 16. What is this?
4. So y power 4.
Yeah, exactly. I need to distribute it.
4 power 2. Wait, oh no,
I've made a
no.
mistake.
Sorry, no, it's 4 power 2. 4 power 4, I think, yeah.
Yeah. And x to the power of?
8. Sorry,
Yeah, okay.
I didn't see it.
Yeah, okay. Anyway, it's okay. So right now, I don't want to waste your time. To do another example. I think you got it very well. Let me try to go over something else. What about the negative power? Let me tell you something. Whenever we have a negative power, we need to handle it. We need to turn it into positive. But you might be asking yourself, how could he turn it? Let me show you something. If you have 7 raised to the power of -2, but this one, it seems like I'm trying to get the reciprocal. Do you know the reciprocal?
Yeah, well, it's like you flip it. That's how I
So
memorize
this
it.
one seems like 7 to the power of -2 over 1. I need to turn it. I need to, to deal with a positive number, not negative number, which makes sense. I need to switch the places. So I'm going to try to flip it. So it's going to be 1 over 7 to the power of 2, which makes sense. This one's going to be 1 over 49, right?
Yes, right.
So what if we have something else? Let me try to make it just, much more harder than this one. But before doing that, let me give you an example. What if you have 3 over 4 raised to the power of -2? So, the first thing, I need to get rid of the negative. But you have to ask yourself, how could I get rid of the negative? By flipping the fraction, if you try to use the reciprocal, the power, it becomes positive. Let me show you. This one seems like 3 over 4. If we try to change it into 4/3, so it becomes positive, right?
Right.
Because I use the reciprocal. And right now we need to distribute the power all over every single number inside it. So it makes sense that we have 4 power 2 over 3 power 2. So this one's going to be 16 over 9, right?
Right.
What if you have something else? For example, right now we are dealing with algebraic expression. Let me try to write it. 2 power 8, z power 4, y power -2. Let me try to use another letter. X to the power of -4. And here we have z to the power of -4, -2, y to the power of -6, and x to the power of 2. This one, to be honest, is quite a bit harder. Do you know why? Because no need to change all places, because right now, I'm looking for which one of them contains a negative power. Let me apply this one. We have 2 to the power of 8 and 2 to the power of 2. 2 to the power of 4. And I told you at the beginning of the session that we have a rule: whenever we have the same pace, we need to subtract the power. So this one, let me get the expansion. So 8 minus 4 is going to be 2 to the power of 4, right?
Right.
And I think you have noticed that I tried to write it at the upper part because it makes sense that the greater one of them has been written in the upper part, right?
Right.
Here we have z power 4. I'll not do anything because it's already positive, right? So no need to change the places whenever we have a positive number. So just keep it. So I'm gonna keep it as z bar 4. What about z to the power of -2? I need to handle it. I need to change it. So whenever you have negative power, you need to change the places. If it was in the denominator, you need to turn it into numerator, and the vice versa, right? So I need to move it to the upper part, so it's going to be z to the power of 2. What about y to the power of -2 and y to the power of -6? Let me try to change their places, right? So it's going to be y power 6 because I moved it, right, over y power 2. Is this one clear for you?
Yes. What about the bottom row now? How do we do that?
No, wait, hold on. I haven't done it yet. I still have x power 2. What do you think about x power 2? Am I supposed to move it?
No, you're not supposed to move it.
Yeah, you're right. Let me try to keep it as x power 2. What about the last one? I need to turn it into, to move it down. So it's going to be x power 4. And right now, I turned all of them into positive, right? Makes sense. So we know, we no longer have negative power anymore. Anyway, 2 to the power 4, it's going to be 16. And here we have z power 4 and z power 2. Let me try to add them together. So this one's going to be z power 6, right? Makes sense. What about those?
Which ones?
Y power 6 and y power 2.
Y power 6. Except minus them.
You're right. Yeah, I'm waiting for you.
Oh. So it will be y power 6 to minus y power 2, which is y power 4.
Yeah, let me try to write it. I'll write it over there, right? What about those two numbers together? Two variables
We
together?
plus them. We plus them. So it's
Yeah,
x power 6.
perfect. X power 6. Makes sense. I'm done. Right now, I turned every single negative power into positive number.
So if there's an equation where it has negative powers and positive powers, you just um flip the negative power. Flip the
Yeah,
negative power.
you're
Okay.
right. You're in the 10th grade or 9th grade?
10th.
Yeah, okay. Let me show you something. Just wait for me. Someone is ringing me. Okay, I'm gonna give you an equation. It helps you to understand what I mean exactly. If you have right over there, 3 power n, which makes sense, equal to 1 over 9. And he told me what is the value of n. So in this case, I'm trying to use my mind. We have the left-hand side and right-hand side, and both of them are equal to each other, which makes sense as this one, I'm going to keep it 3 to the power of n, right? It makes sense. What about this one? Instead of writing 9, I know that 9 seems like 3 power 2, right?
Yeah.
But, I need to move it up. To the upper part. What should I do?
You
Use
should
negative.
do flip it, yeah, negative.
Yeah. So this one's going to be 3 power n, which equal to 3 power -2. Whenever we have the same base, we have a rule. This rule, it tells us whenever we have the same base. So if the base equal to base, so the power equal to power, it makes sense. So n equal to -2. Did you get it?
Yeah, okay.
So right now, the negative power tells me to solve it, to work out this equation. Did you get it?
Yeah, I got it. Okay.
Is this one clear for you?
Yes.
What else? No, unfortunately, we don't have enough time to discuss all subjects you told me at the beginning of the session. Anyway,
It's fractional indices where it's not a whole number or a negative number.
yeah, I know, but yeah, okay. A couple minutes to discuss it with you. This one, it seems like I'm trying to turn it from series to radical. Radical into exponential. Let me show you how. If we have right over there cubic root x power 2, for example, I want to turn it So what should I do? So in this case, let me tell you something. We have a rule. You need to write just x, right? And pay attention. I need to write it as in a fractional form. I mean, the exponent in a fractional form. But remember, inside over outside. So it makes sense that this one over this one, so it's going to be 2/3. Did you get it?
Oh, that makes sense. Okay, so it's the inside over the outside because I thought it was gonna be
Yeah.
3/2 because of the outside. Okay, got it.
What if you have, fifth root x power 10, for example? So this one, if you want to make it simple, it's pretty easy, by the way. But remember the rule, inside over outside makes sense. This one, x to the power of 2, right? Why do you get like why x to the power of 2? Because I try to apply the same rule. 10 divided 5 makes sense. This one's going to be x power 2 over x squared. Do you get it?
Okay, I got it.
So let me give you the last thing. Here we have 64 x power 9 y power 5, for example, and they want to turn it into exponential. So cubic root of 64, what do you think?
Cubic root of 64, I think it's 4.
Yeah, exactly. And what about x?
4x cubic root.
You mean x cubic, right?
Yeah, x cubic. No, like yeah, that's what I meant. Sorry.
What about y?
Y 5/3.
Yeah, did you get it?
Yeah. What if it gives you the fraction like it's
Yeah, I know. You mean the opposite.
yeah, so you don't have to convert it. It gives it to you and you have to do the equation.
You mean
Yeah.
like this one, right?
Yeah, and if it's y like a number, like a whole number, or if it's like a letter, like y.
Yeah, I know. So anyway, this one you could write it as y. Remember, this is going to be for y. So you could write y produces about 5. Here we have cubic root. I try to do the opposite.
Right, that makes sense. Okay. Okay.
Wait, hold on. I have to ask. I have another session. Just wait, hold
It's okay.
on. He hasn't answered me. So let me give another example. What if we have y to the power 2/3? How could I do this one? Could you tell me?
Y to the power of 2/3. It would be square root y to the cubic power of cubic.
I'm gonna use cubic root, right? Makes sense. And this one for y.
Oh,
So
I got it wrong. I did the opposite.
Oh, okay. Um, one more time. What if we have 4/5?
It will be for like cube root 5 to be root 5 and y to the power of 4.
Yeah, perfect. Do it again. So, okay. Hopefully you get it. You get the
Okay, can
point.
I just ask one question? What if
Yeah,
the
sure.
y is a whole number? Like it's like 50 something or like it's a whole number? Because that might be we
Yeah,
brought
you
up
could
in the
apply the
exams.
same
The same
thing.
thing?
Yeah, it's the same thing. Let me show you. If we have, for example, something like this one, this one's gonna be like cubic root. So you could write it at 50 to this one seems like 1, right? But whenever we have the exponent as 1, you don't have to write it. So it's gonna be 50 to the power. Is this one clear for you?
Yes.
Okay. And see you the next time, inshallah.
See you.
Bye.
Goodbye.